Welcome everyone. Welcome in next lecture of vehicle and traffic consideration for pavement design. The This lecture will mainly cover that how much the traffic and vehicle parameters characteristic are important for pavement design. So when we usually talk about the traffic consideration, so we include different parameter. Similarly, when we talk about vehicles, so then we talk about different type of approaches such as volume, density, and so on. So the lecture will mainly cover that why the traffic is so much important, and the second part is about that what are the two different type of traffic approaches when we have the fixed traffic condition, and then when we have the fixed vehicle approach. And we will also talk about the different type of a design method such as empirical method, which is mainly based on the soil strength and so on. We will also try to understand the problem on the group index method, GI method as well. We will also try to determine the CBR method as well, that how we can understand the pavement thickness. Okay, coming to the very first slide. Okay, so traffic is considered as one of the most important parameter to design the pavement, which consider different type of a traffic consideration and characteristic. We need to understand that which type of vehicle we have, such as LTV or HTV. We also need to understand that how much traffic volume do we have in like per hour in different sections as well. We need to understand the mode of operation. Is it a mixed type of a traffic? It's a dedicated system. So and we also need to understand that what are the vehicles consideration that we need to consider at a design stage, that is the maximum wheel load, the total traffic load within 1 hour. And then we also need to consider the tire spacing, as maybe you have idea each and every vehicle have different tire spacing and tire pressure as well. We also need to consider the traffic operational speed as well. Okay, the first part is about the fixed traffic approach. This basic traffic consideration is mainly based on the two basic principles. The first one is regarding fixed traffic approach. In this type of a approach, we usually consider the thickness of the pavement, which is related with the single wheel load. Okay, and also we need to consider the number of repetition of the wheel wheel load is also not considered. So like the thickness of the pavement, which is directly like only related to the single wheel load. Okay, but the number of repetition is not considered. So practically the pavement is subjected to the multiple wheel load, and then for the designing purpose we also consider the multiple wheel load, which is again converted to the single equivalent load. Okay, so the heaviest load, for example, if we have different type of a mode of operation such as 8 ton, 9 ton, and 10 ton, and 12 ton, and so on. So we need to consider according to that specific method the heaviest wheel load, which is also considered quite critical for the design purpose as well. So this method has been used mostly for the for so many years for the court pavement, for the highway, which also like mainly use for the traffic load as well. Okay, but this is one of the old approach which is nowadays rarely used for the pavement design. So in this system, so we considered the total passes of the string of the standard vehicle, along with the how much the number of repetition of the load, and then we add the same factor with the heavy wheel load as well. The next part is about fixed vehicle approach. Okay, in this approach, the thickness of the pavement is governed by the number of repetition of the standard axle or standard wheel load, which is usually taken as 8 to 9 ton in the local context. Practically, the axle load will not be equal to the standard axle load, okay, but should be converted to the standard axle load by using equivalent axle load factor, which we call EALF, okay. Each vehicle practically passing over the pavement is expressed in terms of standard axle, and repetition are also so it express in terms of standard axle, and repetition are also counted. So finally, the total standard axle is obtained by the summation or the total of the standard axle of all vehicles which are passing through that specific pavement during the design period, as well as the total standard axle will be the single parameter for the designing factor as well, okay. As you can see here, so we have a factor and limit for each factor. We also consider the repetition relation with the pavement temperature. The next method is empirical method. So empirical method is based on the soil classification and some other factors such as climate condition and moisture condition. So all of them are quite important. So but the only problem is that such type of a method needs more sophisticated and comprehensive data, which is sometimes really hard to get from the field. The second method is empirical method based method, which is based on the soil strength. So in this specific method of the pavement, the phenomena is correlated with the soil strength. So it is basically based on the or like the all the assumption are basically based on the soil strength and CBR values and so on, okay. The third part is theoretical and semi-theoretical approach. This method is based on the laboratory test and input variable from the field such as wheel load or axle load, and also the correlation with the output variables such as stress, strain, deformation, and so on, okay. The next method is about the method which where we consider the road test parameter. So such type of method is originally based on the information or observation from the test which is already done in the pavement. So those information are again converted into the correlation equation which are used for pavement design. The most important method of these method that it is basically also use or essential part of the Ashto method for the road design as well. The last method, the second last one, is about the group index method. This method was suggested by the Highway Research Board in almost 1940 or 45. The method is basically the estimation of the pavement thickness, which is totally based on the performance of a subgrade soil, which is expressed in terms of group index, which is called GI, which is just denoted with GI method as well, okay. So GI is an empirical quantity which is used for the rating to give the strength to the subgrade soil. So we can obtain the same GI from the formula which is already mentioned here. So GI is equal to F into 200 minus 35 and so on, okay. So this is, you can see here, according to the formula, we have the three type of factor which are basically used here, okay. The one is liquid limit, another one is plastic limit, and third one is plasticity index, while the fourth one is we also try to identify those value which pass the 200 CV, okay. So the performance of subgrade is inversely proportional to the GI value. So if we have the higher value of the GI, the strength of the subgrade will be lower. So performance of the subgrade soil is usually having higher GI, like if it's up to 20 is considered very poor. The subgrade is also compacted to 95% and subbase as well, and subbase is compacted up to 100% of their ashto according to the standard Proctor test or standard Proctor density test. If we talk about the GI method drawback, so the GI have one drawback, which is because of that specific indication, it is not further used. In this method, the pavement thickness is totally based on the subgrade performance for the given traffic and properties of the pavement materials, which are taken into account. Okay. Group index method to design the flexible pavement is basically the empirical approach or method through which we assess or analyze the physical properties of the soil subgrade. So group index is a number which basically assigned to the soil, which is actually based on it soil physical properties such as particle size, liquid limit, plastic limit, and so on. All those values usually vary from 0 to 20. So lower the value, higher is the quality of the subgrade. While if the value is greater, so the subgrade quality is poor. We have usually two type of a method. One is a mathematical method, while another one is graphical method. In this specific lecture, we will resolve the problem through mathematical as well as through graphical method as well. As you can see here, from the top, wheel is acting and the load is basically distributing over a large area. So it means that load is transmitting and distributed. So the performance of the subgrade layer or the supporting layer is very much important. If the subgrade is, you can see here, the last leg is almost reaching to the subgrade limit. So if the value of the subgrade or the physical property or the supportive property is not according to the standard, so there is a huge chances that there could be a deterioration in the pavement life before it's designed. So this is just a mathematical abbreviation for your analysis, that how we can get the value of the GA. So this is one formula, as you can see here, 0.2a plus 0.005 AC plus 0.101 BD. So A is basically all those percentage which actually passes on 200 CV, but it should be between 35 and 75. Similarly B, while the C is actually the liquid limit. So the liquid limit should not exceeding 60 percent, while the if we talk about the plasticity index PI, which is the difference between liquid limit and plastic limit, so it should also be within the range of a 30. Okay. This is the second method through which we can also determine the graphically that how we can design the flexible pavement subgrade. But keep in mind, GI method is only used for the subgrade size, length, or that the specific pavement have how much subgrade value it should have. Is all those method is we have discussed from the top, from number 1 to number 5. The only problem in all those methodology that they are actually focusing in a very specific and confined scenario. Okay. As you can see here, according to the GI value range of different sides, so for the good side it should be between 0 to 1, while for the fair side it should be between 2 to 4 for the poor, and so on. As you can see here, this is the in the bottom along the x-axis, which value is basically given in the inches. So from here you can derive if the value is excellent or not. Okay, so above we have the group index of the subgrade. So below is basically is you can see here is the recommended subgrade level or subgrade thickness, that how much subgrade thickness it should have. Okay, so this is one numerical problem. Okay, so which we try to identify through the method. For example, if we have the value of a number 10 CV is passing 96%, similarly on the 40, and then on the 200. So if we would like to determine the GI value, then how it is possible. Okay, so this is very simple formula. So if we put all the parameters here, okay, so we can get the value. Okay, by resolving this simple equation, so we have the value of a 14.5 somehow, so we will use usually the whole number. So like we will use 15. Okay, so how it is very poor. So let's back to the original chart again. Okay, so the traffic volume is we have already derived. So it's according to the traffic medium, which was already uh, given as well. So it was 150. Okay, so is you can see here we have different CBR graph. Okay, such as CBR A, B, C, D, E, and so on. Okay, so what are basically A? So the curve A is basically it gave the thickness of the sub base course for all traffic types. So A is only related to the traffic. So if we have the design traffic of a 150, so that means that we will go exactly to the curve number A. So if we talk about the curve number B, so it is basically the total thickness of the pavement. So it means that thickness of surface course, base course, and sub base for the light traffic. Okay, where we have the vehicle usually less than 50 for like a single day. If we talk about the number C, so it gives overall thickness for the medium type of a traffic, where the vehicle passes should be less than 300. If we talk about D, so when we have the vehicle passes for more than 300. So the number E, it actually gave us the additional base thickness, which may be like which uh, which is basically the sub base thickness of a curve A, if sub base is not to be provided. As maybe you have idea of, we have the assumption in the pavement design that sub base may or may not be provided. So the next one is curve F, which gave us the overall thickness of the pavement for the light traffic when the when sub base course is present. Okay, and then so on. So this is basically the graphical representation. So this is one of the problem. Okay, so the following lab tests were obtained from the subgrade material, so which passes on 200, so is equal to 58, liquid limit is 30, plastic limit is 200. So we would like to design the pavement for the 200 vehicles are passing. So if 200 vehicles are passing, so that means that so we have the if we would like to resolve the same problem with the graphical method, so directly we will jump to the curve C. Okay, is you can see here we have the formula. So if 200 minus 35 into 0.02 plus 0.005 into liquid limit minus 40 plus 0.01 into if 200 minus 15 into pi minus 10. So if 200 means all the material which like the passing it 200 cv, okay. LL means liquid limit, while pi means plastic limit, which is basically equal to liquid limit minus plastic limit. So all the formula is already there. So we have the GI value of 3 or 4. So it means that subgrade strength is very poor. This is CBR graph method through which we determine the value of the pavement thickness, which we compare it with the value of CBR. So first of all, we get the California bearing ratio, like the bottom capacity limit, the bearing capacity, and then we compare it with the traffic consideration, which is already provided in terms of a light traffic, medium traffic, and heavy traffic. So on the basis of all those assumption, we can come up with the pavement thickness value. But all those approaches are quite predetermined, so the graph is actually based on the CBR method, so which could not be always applied because of the shortcomings and assumption and limited approach of the CBR. But this is only for the understanding purpose, okay. So that it means that on the basis of CBR value, for example, before we have learned that if we have the like the other thickness layer, so is it possible to determine the subgrade level, that how much subgrade level it should have. So now we have the value of a CBR of the material, okay, of the bearing capacity, and we would like to determine that how much pavement thickness it should have if we have the traffic consideration or traffic characteristic and that specific constraint, okay. I hope that you have understand the basic concept that how we can determine the value graphically. Thank you.